let's start the next session. It's my pleasure again to welcome and introduce Aaron Dutter, who's going to talk about sustainability with performance and resilience testing. Aaron has over 17 years of managing end-to-end performance testing. He's spoken at multiple international testing conferences and global webinars. He's got several blogs and they've been published in different global testing forums. He's also won some internal and external awards. He's currently working as an Associate Director of Enterprise Performance and Resilience Testing Practice in LTI Mindtree. Aaron, over to you.
Hey, hi everyone. Hope you can see me, right?
Yeah, you look good.
Yeah. Okay. Thank you. So, let's go. Good afternoon and welcome to SIGiST 2023. I am Murun Kumar Datta and today I will talk about sustainability with performance and resiliency testing. We all know sustainability is the need of the hour, and we also know that performance and resilience is absolutely a must thing for any software product, right? So, and you'll be amazed to know that performance and resilience tester as well as engineers knowingly or unknowingly supports in sustainability. So from agenda perspective, today I'll talk about what is sustainability and carbon footprint, and then I'll start like why sustainability is so important to information technology, and then I'll come how anyone can learn sustainability concept from my experiences. I personally feel like we all IT people should learn the sustainability concept. So I'll share my personal experiences, how I start sustainability and doing that. And then I'll say like performance and resiliency testing, how it is related to carbon footprint, how people are actually knowingly or unknowingly support sustainability. And then how web performance optimization is better for carbon footprint. And lastly, I'll share some of my published blogs in terms of sustainability and carbon footprint for future reading perspective. I'll not spend much time as already Paul have actually given me a idea of what I am and what I did. So I'll just skip that slide and let's start with the knowing what is sustainability. I think we all are hearing the sustainability word, probably we all testers and the developers and all the operation people, everybody is talking about sustainability, and it is absolutely need of the hour, right? So sustainability is meeting our own needs without affecting the future generation needs. So we have to think about our future generation. We cannot think about only for ourselves. We have to think about our future generation also. And we also need to think about the environment. By the way, sustainability not only means by environment, it also means environment, economy, and society. So basically, sustainability has three pillars called as environment, economy, and society. And sustainability has many benefits. If you talk about the benefit perspective, I'll say like sustainability helps in a healthier environment. It ensures energy consumption. It plays a major role in employment as well as in economy, right? And then the most important thing is sustainability helps in a good public health, right? It is a catalyst of good public health. Why I'm saying it is a public and catalyst of good public health? Because after COVID, we all started understanding how important is our health, right? And sustainability helps in that. So overall, sustainability guarantees a better future for all of us. And that is why sustainability is so much important for us. We have to think about ourselves definitely, but we also have to think about future generation. And then again, sustainability is everyone's responsibility. Everyone, when I say everyone, I'm trying to say like all of us. No matter what background we came from or what we do, but we all have to think about sustainability. We all have to think about reducing the carbon footprint to the society or reduce the energy consumption of the society so that we can make a better and sustainable environment. So what is carbon footprint? A carbon footprint is the total amount of greenhouse gases that are generated by our action. So when I say like greenhouse gases, it mostly the carbon dioxide and methane. Those are the two primary gases which actually been used as greenhouse gases. There are a few more, like ozone could be one, or maybe like nitrous oxide could be one, or hydrochlorofluorocarbons could be one, hydrochlorocarbons could be one. So there are other greenhouse gases also, but mostly carbon dioxide and methane are the two major greenhouse gases which actually creates a lot of carbon footprint, right? And if you look at these people, product, industries, organizations, everything has a carbon footprint. So it is like, it depends on what you actually do as your day-to-day actions, right? So for an example, like the way you commute, or maybe like the food that you eat, or probably the clothes that you wear, or even the products that you use, your gadgets, your devices, the things that you throw away as a garbage, everything, every your daily actions literally has a carbon footprint. So we all have to, whether it's a people, whether it's a product, whether it's industries, organizations, we all have to think in cautiously so that we make the carbon footprint lesser, right? That is the whole thought process, and that is what I see. The larger your carbon footprint, the heavier it is to the environment, and it is not good for the society. So we have to try to do such a way that your carbon footprint gets reduced. I will also say some of the way, like our software industry, or probably the testing perspective, like we are all are testers, right? So we'll say like how the testers can actually do those things, like to make sure the carbon footprint is reduced, right? So our ultimate goal is to reduce the carbon footprint. Now let's talk about IT and sustainability, right? So if you look at the IT contains many servers, or maybe like server farms or devices, a lot of machines, right? And we are in the age of IoTs, where we are talking about a lot of devices. Basically, IoT or Internet of Things actually massively added devices, right? So all these devices or equipments or servers or server farms all needs a huge amount of energy. Without energy, it cannot run, right? And they need all these machines, devices also has a carbon footprint, right? Because it generates a massive amount of greenhouse gases. So it's a form of carbon dioxide, it's a form of methane, but basically it generates a lot of greenhouse gases, which actually has a huge carbon footprint. And as we are saying, so many devices, so many server farms and the equipments, those are generating a lot of heat. So to cool those machines, we also have to put another source of heat, another source of energy to make those cool, right? Otherwise, those machines will be generating those heats, right? So resulting, it creates more, it requires more energy to cool down, right? So in terms of it, to power on, to serve those servers or server farms or devices, it needs energies, and they have carbon footprint, and they need extra amount of energy to cool those machines or equipments, right? So all these three leads to a bad sustainability, and that is why we call as we need to think about the sustainability. And then again, we are talking about internet, and today internet is the biggest place of carbon footprint, and it has a huge environmental impact, right? So basically what I'm trying to say is we all have to think about make IT as green, okay? We have to think about reducing the carbon footprint, or thinking about the sustainability for a better world to our future generation. And that is why we all have to think about it. That is why sustainability, or knowing sustainability for all of us, whether it's a tester, whether it's a developer, whether it works for operation team, or whether it's business analyst, we all have to think in such a way that we can make IT as a green. And that I think everybody will be agreeing at this moment. Now I'll tell you how we can all learn those concepts. I'll say there are two very good courses that I went through, and probably you guys can all go through, and both the courses are free. One by Green Software Foundation and the Linux Foundation, we call as a Green Software for Practitioners, LFC 131, as you see on the screen, right? And then there are another one by Microsoft, we call as a Principles of Software, Sustainable Software Engineering, right? Both the courses are free, and the best part is like even you can get a free certification also if you pass an exam after going through all these courses. And I'll say like that it's not restricted to those two courses. There are a lot of other courses available on different sites. Probably those are paid, or maybe there will be some free courses. But these are both the courses I went through that comes from my personal experiences. And then again, if you want to learn more after going through both the courses, you can go through a lot of blogs, forums, or discussions, the conferences that nowadays going on, and based on your interests and the things. But what I'm trying to say is like, we all need to understand and work in such a way that IT becomes green. And we also all have to think about reducing carbon footprint and reducing the energy consumption so that we can make this world a sustainable place for our future generations. So that was my first part of the presentation, where I talked about sustainability, carbon footprint, and why green IT is required, right? Now I'll come back to the testing aspect of this and why. And as I said on the very beginning, like performance testers or engineers knowingly or unknowingly actually supports in sustainability, right? So how does they do it? They basically does in two ways, okay? First, as I said, like we all performance testers or engineers always try to think about making the applications or the websites or APIs faster, right? That is what our job is, and that is what we are doing every time, right? Now, if your application is faster or your website is faster, it uses less data to serve the request, right? The moment it uses less data to serve the request, it actually emits the less carbon, right? So so less carbon will be omission, right? That is what the first part. And the second part is, we performance tester always thinks about optimizing the server resources, and that is our job, right? And if it is an optimized server resources, then basically it consumes less energy, right? The moment it will be optimized, it will be consuming less energy, right? And that is why, which is better for our environment. And so that's how, like, optimizing the server resources. So there are two ways performance testers and performance engineers helps in sustainability or reducing the carbon footprint. One by making the application faster, and one by optimizing the server resources. And both these are performance tester or performance engineer's job. Let me tell it in a little bit more way. Probably it will be easier for you, all of you, to understand, right? Let's talk about an on-premises solution. So when I say the on-premises solution, we are thinking about the traditional data center, right? So traditional data center doesn't have the flexibility to add resources very quickly. They cannot add a server then and there, right? It takes time. It takes a lot of approval. It goes a lot of processes. Then only they can add few resources. But they also have a pressure, as they cannot scale it so quickly. They always have a pressure, because there will be always, they always have to think about the future volume, or they might have to think about the future business growth, or maybe there will be a lot of spike condition like fraud. If you think about a Black Friday kind of conditions in US, or probably in India, if you think about a Diwali sale kind of things, right? Where there will be huge loads will come into the system. So your data center has to have support those many numbers of users, right? So always the tendency for data centers is you always have a more resources. So you will add more resources, you will have more servers just to scatter or support that those extreme conditions, whether it is a kind of a future business growth or future volume or a kind of a spike condition, right? But this all leads to, if you think about that, basically it increases the cost, because it will happen on a certain point of time, or it will happen after some time, right? So basically it increase the cost. So that is one aspect, but it also increase a huge energy consumption is going to happen, right? Because those machines or those servers will be using the energy, right? And they will also generate a lot of greenhouse gases, right? So basically it will be having a huge carbon footprint. So what we are trying to say is, like, you have to think about optimizing those server resources so that it is always good for the society. But traditional data centers are not at all good for the sustainable things. We have to think about sustainable capacity planning. We have to think about optimized resource utilization, and we have to do it by conducting continuous performance testing, monitoring, and engineering, right? And that is the only way you can say it, like, yes, your application can sustain up to this many numbers of users, or it can scalable up to that many numbers of users, right? And that is how you can tell us, no, you can go ahead with this one, and that is optimizing your server resources, and that is where performance tester or engineers plays a role, right? So whether you have to do the continuous performance testing for sure, but you also have to think about other optimization thing like adapting optimized resource driven high availability context that nowadays people are actually using it, right? Or maybe like you can think about application containerization. So those kind of processes you have to bring it in your data center so that it actually been optimized for the server resources. And then again, like you can also think about some of other ways, like I call it as a hardware efficiency. If you go with the sustainability concept, so what that hardware efficiency is, you can increasing those utilization. So for an example, in ideal cases, most of the data center works on a 20 to 30% utilization. Most of the data center, right? They do not go only when there is a huge load or there is a spike condition. Then only it will reach up to 40 to 50 or maybe 60%. But in sustainability aspects, you have to think about 70% utilized. You have to think about more utilization of your server resources. And that is how hardware efficiency will come. It will give you more sustainable things. It will generate less carbon footprint, right? And then again, you can also think about expanding the lifespan of your devices. So either you can use your machine for longer duration. For an example, you are using an iPhone, right? So if you are using an iPhone, normally people use it for 3 years, right? So what sustainable concept tells, or hardware efficiency, you use it for 5 years. So the amount of greenhouse gas that will be emitted from that particular iPhone is going to be reduced, divided by 5 years rather than 3 years. So your carbon footprint to the society will be less, right? So either you can increase the hardware efficiency by increasing the utilization, or you can think about expanding the lifespan of your server. And lastly, okay, so that was our on-premises thing. Now let's talk about the cloud. And we all know cloud is sustainable, right? Because it uses green energy, it uses the clean energy. So moving your application to cloud itself brings a lot of sustainability, and you don't have to worry about it, right? Because cloud itself is having a reduced carbon footprint. And then again, cloud has the flexibility to scale up and down very easily. They have auto scaling facility. There are a lot of other benefits, right? But then again, I will say like optimized application which migrates to cloud gives you better sustainability rather than unoptimized application which moves to the cloud. And I have actually published one of the blog article back in 2020 in Eurostar Hurdle, where I talked about how the application don't run fast in the cloud, right? Without optimizing. So what I'm trying to say is like, first you make sure you are optimizing your application, and then you start thinking about moving to the cloud. Otherwise, what will happen, like you will going to get some amount of scalability for sure, but your cost will be some amount of sustainability for sure, but your application will not be that performance enough, or your maybe the cloud cost in long run will be high. So that is how you have to think about, and that you can do only by conducting continuous performance testing and monitoring, and probably kind of a performance engineering or tuning, those kind of things. And that's how we are going to get a fully optimized application in your cloud, which will gives you a better sustainable rather than an unoptimized application which moves back to the cloud. So we all have to think about it, right? Let's talk about another aspect, which I call as a web performance optimization, right? So when I say like how performance testers or maybe like the performance engineer supports in sustainability, I talked on my last slide again that when your application is faster, it uses less data, right? And that faster you can easily make it through web performance optimization, right? And if you wanted to do web performance optimization, you have to do it by doing continuous performance testing or continuous performance monitoring. And then you analyze the performance and then of your web application pages. And then again, you do a certain round of optimizations or probably kind of tuning that you do. And you do again, ensuring that, so another round of performance testing can be called as, we call as iterative round of performance testing, and ensure that it actually improves. So performance optimization definitely helps in having less or maybe like reduced carbon footprint, which is better for our society, which is better for the sustainable environment, right? And it does both ways, right? Whether it is a client-side optimization or whether it's a server-side optimization, right? So if you think about the client-side optimization, if you are a performance tester, you can easily identify like it can be initial page load time or probably JavaScript that runs in the browser or downloading all the resources, and there will be a lot more, right? So client-side performance optimization is a big thing that we are doing, and there are a lot of companies nowadays working, whether it's a catch point or there is a lot of performance monitoring tool, which in terms supports the performance testers or engineers to do that. So it is a big set of activities that we people are every day working on our day-to-day work, right? And then, sorry, then there is another aspect which is called as a server-side optimization, right? So while server-side, when we are talking about server-side, basically a web server or it could be app server or it could be DB server, but it can also be a DB queries where you are improving your DB queries performance, because if you think about a thumb loop or a performance testing side, most of your performance problems are maybe like 70% of your performance problem lies on the database, right? That's what the thumb rule says, right? So you can think about the DB queries, or you can think about a lot of application depending components. Sorry. So which can help in the server side optimization, both on the client side perspective as well as from the server side perspective. We can do the web performance optimization, and web performance optimization definitely helps in reducing the carbon footprint. Sorry. So let's talk about some of the web performance optimization techniques. Okay, there are a lot of best practices that are available, and people are actually using it, right? Yeah, could be one which you all know about, the caching things, right? So that can actually improve the application performance. Or maybe like you can think about content delivery network, right? Nowadays for cloud, probably people are all thinking about putting the content delivery network for improving performance and resiliency from near end users. So somebody who is sitting on the Delhi or Mumbai, when servers is on probably London, will not get that extra latency because of the content delivery network. So that's how onshore performance has been improved, right? Or maybe like you can think about a lot of techniques like bundling or minification or syncing file sizes. So all are like reducing the file sizing technique. So your file size gets reduced, so it will emit actually less data and it will transfer it quickly. Okay, so that's how it actually helps in performance optimization as well as in carbon footprint, right? And then again, like you can also think about a lot of optimizing usage of images or reduce number of resources or web pages. So those are the things that you can definitely think about it, right? And maybe like minimizing the data duplication process, or maybe like the storage consumption. So there are a lot of best practices that web performance optimization tells, and we can all follow this. And these all not only leads to performance optimization, basically it actually reduces the energy usage and it requires less data to serve the request. And that's how the better sustainability or less carbon footprint comes into the picture, right? And you can even think about optimizing usage of images on your specific page. Less images always gives you a better sustainability, right? And then you can reduce the number of resources if possible. So those are the things that actually can be. So what I'm trying to say is like your goal should be your pages or your web pages should be more linear. So the more linear it will be, the less carbon footprint it will emit. So that is actually good for the society or good for the environment. And I'll say like, or maybe like it is a positive part that every performance testers or performance engineers are actually loves to work on this web performance optimization. That's how they help in sustainability also. There are other best practices also available for sustainability perspective, like you can create environments only when required. So nowadays, as we have the flexibility of cloud, or maybe like we are actually using a lot of automated deployment scripts because of DevOps been so much mature nowadays. So creating environments doesn't take time, right? So you can do it quickly. We can do it in minutes rather than days or the hours that earlier used to take, right? So use or create the environments only when it is required. If it is not required, do not use it. Don't keep them running. You can close it. You can decommission this. and only when it is required, you can actually create environments, do the testing and close it, whether it's a normal testing or there's a performance and resilience testing, right? So you can think about it. And this saves a lot of resources, it reduces the energy, it has a lot of means less or reduced carbon footprint. So always actually been better for your sustainability perspective. You can think about the green testing practices. So when I say green testing practices, what I mean is like you have to leverage the containerization concept, or you can think about virtualization concept, right? Nowadays we all are using, and use that virtualization containerization concept on your testing purposes, whether it's a typical functional or manual testing, or is it a automation testing, or it is a performance and resilient testing. You can use all here, and it actually reduces the hardware usage, or it actually reduces the energy consumption. However, it actually gives you a lot of better test coverage with fewer resources. So you have less resources, but you have better test coverage. It's both actually good, and that is how we call as a green testing practices. You can think about a lot of optimized power management things, basically both on the server side as well as from the workstation perspective. When you are, means if you are not using, you actually reduce the energy consumption. So where the thumb rule says is, if you are using a during a periods of low usage, like on a night time on your cases, or night time on every location, that time the usage will be less, right? So you try to reduce those machines, or you try to switch off those machines if it's not required, right? So that way it actually helps a lot of powers, a lot of resources in terms of the energy perspective, right? And then I will say, like, as I am a performance tester, I always think about monitoring and analyzing things. So I'll always say, like, you should start thinking about implementing monitoring tool. Why you need monitoring tool? You are not only analyzing the usage of your application, but you also have to think about your infrastructure, or maybe like even your including your CI/CD pipeline, right? So all things are very crucial. So you have a scope of improvement on every places. We always think about your application or the infrastructure. We normally don't think about our CI/CD pipeline or anywhere we are not using it. Try to use those monitoring tools, use those data which you are getting from monitoring things, and then you think about on analyzing the areas of improvement, or areas for improvement, not only in terms of the usage, but also in terms of the optimization. So the moment the optimization comes into the picture, it can actually good for the performance people, it can good for the cost wise also, and then it also reduce the lesser carbon footprint, right? So all aspect it can help. So that is what I always say, monitoring and analyzing is absolutely important. And nowadays we are actually moving to APM to observability tools, and that is how there are a lot of things will come into and there are a lot of things already come, and there are a lot of things will going to come to ensure like resource usage is getting less and we have less carbon footprint. Lastly, I will say, like, I'll be very honest, okay? And the honest in terms of, it's a totally a different angle, okay? Till now, I was talking about how performance testers or engineers actually helps in sustainability. The last segment, or the segment that I'm going to talk now, is a different way. When I'm trying to say, like, you have to avoid unnecessary or unplanned performance and resiliency testing, and you have to do it for reducing the carbon emission. Now we have to understand why, right? Why I'm telling that. So if you look at the performance and resiliency testing, we talked about load testing, we talked about stress testing, we talked about endurance testing, or we talked about the capacity planning, or maybe like volume testing, or even from a resiliency perspective, we talked about game day testing nowadays, or there are a lot of other types of resiliency testing or that we can do, right? So all these have a huge workload, and it is basically driven by thousands of users. And if you think about Internet of Things, we are talking about millions of devices. So all these has a huge workload. Now, when you have a huge workload, it actually has a huge carbon footprint to the society, right? So unnecessary or unplanned performance and resiliency test execution should be strictly avoided. And conducting full-blown performance testing in a very low scale environment, which is actually happens most of the cases. If you look at our experiences perspective, most of the cases you will always get a 30% or 20% scalable environment where you run a full-blown performance testing. And then if your result doesn't match, they will say, oh, because of the scalable, it doesn't match, right? So basically you have to do the same testing again. And then sometimes you are not going to get the actual performance of pre-production environment or targeted state environment. Rather, you are doing it in a very reduced testing environment or probably kind of staging environment, which is not matched with that, right? So both ways actually you have to do it, or you have to do it a lot of extrapolation to ensure that performance result. So basically these things has to be strictly avoided. Why strictly avoided? Because it actually reduces less carbon emission. So you are not going to, I'm not saying like you don't have to do performance testing or resiliency testing, but what I'm trying to say, unnecessary or unplanned performance and resiliency testing should be avoided. And think about another aspect, so probably a different note in terms of that. If performance and resiliency testing having huge carbon footprint, then ChatGPT will be having how much carbon footprint. So while we are all talking about generative AI or we're talking about this ChatGPT's benefit, but ensure these are actually having a huge carbon footprint. So in a nutshell, what I'm trying to say is like organizations need to be very serious when conducting full-blown performance and resiliency testing. And I actually wrote an article on LinkedIn, and you guys can actually go through that if you wanted to read it more about this one, like why unnecessary unplanned performance and resiliency should be avoided. So these are some of my blog articles.
We need to close now. If you
can I'm done. Yeah, thank you.
Sorry.
These are some of my, no, that's fine. I already on my last slide. So these are all my, I'll say like all my blogs now in terms of this carbon footprint and how this thing actually helps in sustainability. So thank you so much.
Aaron, thank you very much indeed.